So you want to solve combination sum. What does it even ask you? Given an array of distinct integers candidates and a target integer target, return a list of all unique combinations of candidates where the chosen numbers sum to target. You may return the combinations in any order. The same order may be chosen from candidates an unlimited number of times. Two combinations are unique if the frequency of at least one of the chosen numbers is different. It is guaranteed that the number of unique combinations that sum up to target is less than 150 combinations for the given input. So actually, this line is completely irrelevant. So let's just take an example. 7 can be done with 2 plus 2 plus 3, or 7. Or 8 can be done with 2 plus 2 plus 2 plus 2, or 2 plus 3 plus 3, or 3 plus 5. Here, you're given a target of 1, and your only candidate is 2, so you can't make 1. 1, and then candidate 1, so you return 1. 2 can be done with 1 plus 1. Okay, so how do we even find that? The first thing we do is we come up with our return vector, which we call myReturn. And that's what we're going to return, myReturn. Now, we just need to fill up this myReturn vector of vectors in some magical way. So myReturn, and then we're going to send in the current vector. We might want to throw in our candidates. We might want to throw in our target. And the position would be 0. And I think that's probably all we need. Now, let's come up with that fill combinations function. So we're going to be passing in myReturn by reference. So let's just copy all of this. So this is going to get filled up as we recurse in myReturn. So this is a classic backtracking problem, and we're going to figure out why in 2 seconds. Also, we have our current vector. We have the candidates, which we're going to pass by reference, just the same way it was given to us. We also have the target, as well as the position. And actually, I think we could pass some of those by reference as well, or const reference specifically. Const reference. So, okay, so let's see how we go about this. The first check that we have to do, okay, so we're going to be calculating these numbers. We're going to be decrementing 8 from the value. So for example, let's say we decrement 2 from 8, we're going to get 6, and then we pass in 2 again, we get 4, and then 2, we get 2, and then 2 again, we get 0. So what we want to do is check whether our target actually equals 0. That means we got somewhere. So if target equals 0, then, well, what we do is we push back our current numbers and we return. So we only get that when we reached our target. Now, if target less than 0, then we return. And what does this even mean? That means that as we're decrementing, if eventually you hit a 9 or something, and you used up that number, you know that you're going to get something less than 0, because 8 minus 9 equals minus 1. So let's just air that out a little bit. And then comes the meat of the problem. So we're going to iterate over candidates, but in such a way, so I starts at our position, and I smaller than candidates dot size, and then I plus plus. Now we want to add to the current dot push back candidates dot I, and in between we're going to pop back whatever we inserted there. But in between this kind of sandwich of pushing and popping, we're going to recurse And how are we going to do that? So we're going to throw in my return again. We're going to throw in current. We're going to throw in candidates. Now the target is target minus, so candidates, keep on writing Canada. That's because you guessed it, I'm Canadian. Next comes position, and that would be I. Yeah, so the only way that it kind of moves up a position is through the iteration here, and it stops going deep inside the candidates as soon as it hits a wall, meaning it added something it's not supposed to. So then it comes back and you're back to your original position, and you could continue iterating down this loop. So let's see if this works. And our survey says yes. And we submit, and we got it going. Thanks again, everyone.